Share screen. Play from start. Hey guys, so my name is Charles Patterson, and today I'm going to be talking to you guys about coreference resolution. And specifically, there's two papers within this topic that I'm going to be talking about. First one is coreference resolution with syntactico-semantic rules and corpus statistics. And then the second one is an NP cluster-based approach to coreference resolution. And yes, that's a mouthful for me too. So first off, I wanted to briefly kind of talk about what coreference resolution is. I don't know how much Dr. King was able to talk about it in class, but since I'm recording this beforehand, I figured I'd just cover my bases. So really quickly, what we're trying to do is pair different noun prepositions to each other within a given corpus. So if there's a noun preposition in one sentence and it's referenced later on in the corpus, we want to be able to link those together. And this allows us to have additional context when we want to do different predictive things, or if we want to tag sentences or do any of our natural language processing techniques. So an example that I came up with is, my dad likes to cook for our family. He's really cool. So here, coreference resolution would hopefully be able to pair my dad in the first sentence to he in the second sentence. But by that same token, he's not, or coreference resolution isn't going to pair our family to he, because that's not the right linking. The right linking would be my dad to he. So that's the goal, is can we connect these two different noun prepositions to each other? So the first paper is coreference resolution with syntactico-semantic rules and corpus statistics. And the main idea, according to the authors, is that this is a new hybrid approach to the coreference resolution problem. It is the CORDIS system, or the coreference rules with disambiguous statistics. And this is going to combine syntactico-semantic rules with statistics derived from an annotated corpus. Or I rephrased it in English to be incorporate traditional rules-based methods of coreference resolution to make our statistics-driven models perform better. So the idea being, like whenever you go to learn a language, you typically have a set of rules that you might learn like in a grammar class or something like that. Never mind. But then you would also, just as you're having conversations with different people, maybe you're watching TV, maybe you're reading books, you just start to kind of pick up on it. And so that's kind of a very natural feel to it. And so the goal is, can we kind of, not unlike how we've learned language, can we kind of combine that, that similar principle when we start to teach a program to do this? So the motivation for this method is that, like I was saying before, we're able to kind of combine because both methods, whether we're talking about statistics or rules, have different strengths to them. The statistics one has the strength of, our models are able to learn, but also it's going to reduce our sparse data problem, which means that we're going to be able to more quickly make predictions and that kind of thing, whereas rules-based is going to be a lot longer. But the advantage of having rules-based is that there are traditional rules that we don't necessarily need to make our program learn. And it would be nice that if we could just kind of plug in some rules so that it would understand what's going on a lot faster, rather than trying to reteach it stuff that we already know and could just plug it in for the computer. So the algorithm for this one comes down to basically 3 steps. What we're going to do is at first, we're going to parse all of the sentences individually according to the rules that we gave it. And we're going to basically go through and assign like, okay, given all these rules, we can basically identify what all the noun prepositions are and see if we can begin to and kind of tell it what are some of what are the possible links. So there's going to be, so I should explain this terminology real quick. There's an anaphor and an antecedent. I don't know how to pronounce that word. I'm so sorry, guys. But anyways, there's basically noun preposition 1 to noun preposition anything that it could connect to. And so our goal is we're basically going to find out, okay, this is the anaphor, and what are all of the different possibilities that it could connect to. we're going to use some rules-based methods to basically identify what are all the different antecedents that it could potentially link to. And then what we'll do at the end, once we kind of have a bunch of different candidates, is we're going to use our statistics-driven model to identify which one are we in fact going to link it to. Now, naturally, there's going to be a couple of problems. So what the author would suggest is, if we only link one anaphor to one antecedent, how do we choose which one? Or as they would say, disambiguate. So essentially, rather than kind of leaving it ambiguous as to, this anaphora connects potentially some of these, we're going to in fact like make a hard link to it. So how do we end up doing that? Well, the first one that we can do is distance. We can kind of measure the distance between the different noun prepositions. So if it's X number of sentences away, or if it's X number of paragraphs away, the further and further and further it gets, the less and less likely they are going to be to connecting. The second one that we're going to look at is semantic compatibility. And what that's going to do is connect it based on whether or not it kind of grammatically makes sense to pair them together. So going back to my example with, my dad really likes to cook, he's really cool. Or my dad really likes to cook for our family, he's really cool. He wouldn't necessarily pair with our family very well because of the person that is. So like, we're not going to connect second, well, I guess, sorry guys, that's kind of embarrassing. Ours would be second person, he would be second person too. But it's my point being that semantically, it wouldn't make sense necessarily to compare ours family, that's kind of plural though, to he. It was still similar idea here. That semantic compatibility doesn't make nearly as much sense as my dad. To evaluate these models, because they are supervised models, we can actually use evaluation metrics, which is really handy, rather than using unsupervised where we have to go in and kind of just look and see, okay, maybe did we cluster this right? Is the results going to make sense? We can actually go in and test, like, okay, how accurate was it or whatever. And now I know I just said accurate, but this paper really pushes the idea that with coreference resolution, we really want to be looking at precision and recall. So for those of you who, it's been a while since you've thought about precision and recall, one is looking at the number of true positives, and one's going to focus more on the true negatives and making sure that we didn't mess those up. And the reason that that's helpful is because we want to be able to focus more on, we don't necessarily want to just focus on accuracy. We want to figure out how many times are we correctly linking them and how many times are we incorrectly linking them and making specific errors on that. So we don't want to have too many false positives or too many false negatives, and trying to reduce both of those simultaneously, as opposed to just looking at accuracy. Okay, now the second paper is an NP cluster-based approach to coreference resolution. And in this one, the main idea is that they're going to propose a supervised learning-based approach, which does coreference resolution by exploring the relationships between noun prepositions and coreferential clusters. So the motivation here is that most coreference models attempt to compare the different noun prepositions to each other. And like our last one, where we had the rules set up, and then we tried to essentially link them using statistics-driven models. But here, their thought is, well, typically, we're going to, it kind of makes sense to begin to cluster these noun prepositions as opposed to trying to link them together. So almost like how I walked through the last example with my dad really likes to cook for our family. He's really cool. We're going to cluster, we should be able to cluster my dad with he together and leave in a different cluster our family. And if we can do that, that might be a more effective and honestly a more, I don't want to say biologically driven, but it seems to me to make a lot more sense even than statistics driven models. So to steal another quote from them, they compared the individual noun prepositions for their co-referential clusters could provide richer information that entails better rules learning and referential determination. And so again, the idea is if we cluster them together, that might be able to outperform the rules-based method. And so we'll see. They go ahead and run it, and then we'll see that they have some results at the end. They did, however, put an asterisk in here that there's a limitation to, you have to have a lot of data. And generally, even within a given data point, it's really hard to give the machine enough information to go on to make adequate inferences. It's actually truly astonishing how well our language and our ability to process language is because of it, because we, from frankly, very little information, are able to connect very strongly our different nouns. And that's actually quite a challenging problem, as it turns out, for natural language processing. All right, so algorithm overview. Essentially what we're going to do is we're going to start from the back and then work our way to the front. So what that means is we're going to go ahead, and so we're going to start with a corpus that's already been tagged. So we already know, okay, here's the noun prepositions. And so what we'll do is we'll start at the end of the corpus and pick the very last noun preposition. Now I'm realizing that I've been using my hands like this, and I should probably start over here because this is probably the ending point for you guys. So you'd start at the end, and then you would work your way backward. And so you're going to take your last noun preposition, and then you're going to use that as a reference for all of the other noun prepositions to cluster them based off of. So for example, if we were going to go back to my very basic example, our last noun preposition would be he, and then it's going to take our family. Okay, we'll put that in one cluster, and then might take my dad and it'll put it in another cluster. And that way we have now two different clusters as reference against this other noun preposition that we came up with. Oh, sorry. The second half of that is once you've been able to cluster them all together, you can then take a look and see, okay, how well are the clusters doing? And then you can also begin to pair the referential noun preposition to the other noun prepositions within that cluster. So let's say that we had a few more noun prepositions, say like 7 of them. We might be able to say, okay, the first one and the 5th noun preposition do seem to link together pretty well. And the referential one, maybe that one belongs in cluster 3. And it really belongs with the second cluster or the second noun preposition and the 6th cluster. And then you can start to link those together. Okay, so the features for this model are going to include the number of noun prepositions in a given cluster that agree. So essentially what you're going to do is you'll take the number of noun prepositions within that cluster, and you're going to see how many of those noun prepositions seem to agree with each other. In more gender-based languages, you might look at gender agreement. So English doesn't really have this, but if you're looking at German or Spanish or Italian, you might look at gender agreement for those different clusters. And then you're also going to look at, once again, semantic agreement. So again, we're going to see, okay, my dad, he, that seems to link pretty well. Our family and he, that doesn't really seem to link well. And so that can kind of factor in. Some additional features they suggested is cluster length. So how many noun prepositions are within any given cluster, and string similarity itself. So if the different strings in those noun prepositions are more similar, then maybe you can cluster those together. It appears that I jumped the gun, and I've already talked about how we train the model. So again, you start from the back, you take your noun preposition, sorry, you start over here, you take your noun preposition, and then you work back into placing all the different noun prepositions into the various clusters. For the results, what they found were if you can include the main 3 features, so these guys, these 3 main features, the model seems to perform very well, but if you don't include any of them, the traditional methods really, we don't really see much of a difference between using the cluster-based approach and this approach. So those 3 main features turn out to be very important when we're doing this. Some things to watch out for is sometimes the clusters don't really do that good a job. So sometimes clusters may base it off of person. So maybe it would link our family to he because they're both second person, whereas my dad would be third person. And so it might cluster it weirdly that way. However, in general, they were saying that the models this way were achieving a 4.6% better recall score and a 1.3% better precision. So in both cases, we're actually able to get better results when we're able to include these three main features into our model. So the conclusion is we have a rules and a statistics-based hybrid model that seems to be better. So going back to paper one, it seems to me that whenever you are able to kind of dovetail rules-based approach and a statistics-based approach, that tends to give you better results for your modeling. Clustering tends to be a very natural way to go about things, and it seems to be producing better results than traditional methods where you might just look at string similarity to pair them together. But the other big one that both papers really emphasized is that this is just frankly a really, really challenging problem. And oftentimes we don't necessarily have the information necessary to get reliable and good results. And so this is a super helpful thing. Maybe if you have a lot of data that it's really worth doing. But in general, this is because it's such a challenging problem, I would struggle to recommend doing something like this on the job just because I don't know how well the results are going to do. Yeah, that would be my presentation. Thank you for listening.